Okay, we're online. I currently have no one in the Hangout, but I need to get started. I'm actually short of battery today. I forgot to bring my power supply. I'm not very smart. And we're just getting rolling, and I'm down to already 69%. So this is going to be interesting, and it might be a little aborted, but we'll see how it goes. So with no one in here, I don't have any questions. I'm going to start looking at some sample questions. So I don't know. Let's start with number 33, and I'll share my screen. I guess I can turn my camera off now, save a little bit of power, and yep, we have that available at the moment. Share. So hopefully all of you are seeing the screen, and we can talk about number 33. The directions in that part were: evaluate the function at each of the specified values of independent variables, and if possible, simplify. So this is one of those piecewise functions where we have two parts to the function defined up at the top there. When x is less than 0, then the formula is 2x plus 1. When x is greater than or equal to 0, then use the formula 2x plus 2. And the book asked us to find the following three: f of -1, f of 0, and f of 2. So really, all you gotta figure out which formula is which. So in the top one, f of -1, for that one, we have to use the top formula because x is obviously less than 0. And when you plug in a -1, -2 plus 1 is -1. F of 0 has to use the bottom formula because the condition on the right says when x is greater than or equal to 0. So 0 plus 2 is 2. And the last one also uses the bottom formula, plug in a 2. So, and I did make a graph, not that we had to use it, but a piecewise function literally has a graph in pieces, and you see how we literally have two chunks to the graph. And why do I have the open circle on the bottom one? Because when x is less than 0, is what this says on the top here. Not less than or equal to, just less than. And the top one does have greater than or equal to 0, so that's why that one begins with a solid dot. It's still a function. If we pass a vertical line through, it's still at the y-axis will only cross in one point. I see we have 5 viewers. Welcome, viewers. Hadn't gotten any questions yet. Don't forget, you can send me some in chat, but in text message if you'd like, and I'll be happy to do those. This just happens to be one I picked out, number 33. All right. Any requests out there? Otherwise, I'm going to just move ahead. Let's take number 45 from last time and take a look at that one. The directions on this part are: find all the real values of x such that f of x equals 0. So what will it be that causes the function f of x to be equal to 0? Well, you can only find out by setting it equal to 0. And then just do pretty basic algebra and solve for x. So in number 45, what value will create a 0 when x is 4/3? I'm going to get rid of my keyboard here. Okay, it looks like we have a request coming in. Let me take a look here. Number 53, and thank you for giving me the name, Alexandra. I appreciate that. I will do number 53 next. Good timing on that request. I'm going to get rid of my keyboard, like I said, so that I can write a little bit better. Okay, 53. Let's see if we have that one. Yep, we do. 53. Okay, the directions here are find the values of x for which f of x equals g of x. So this time they're telling you we have two functions. When will they be equal? Well, the only way to find out is to set them equal, which is what I've done in the first line here and the first line underneath. Now it's just pretty standard. You want eventually we're going to have a problem with this x that's underneath the square root sign here. So what we're going to have to do is get that isolated, and then the plan would be to square both sides. So step one, isolate it. That is, get rid of the +1 that's on the left by subtracting it. Now that we're at this position, we can square both sides, which I've done. 3x equals x squared. Now, there's when you reach this stage, there's actually two possible ways to go. You could divide both sides by x, but you're much better off if you can. You're going to miss the solution if you do that. So it's better to get everything on one side and set equal to 0, like I've done here. Now use factoring, not a very hard kind of factoring, and you'll see that we get two results, 0 and 3. Had we divided both sides by x, then you would have had just 3 equals x, and you only would have found the first solution. So advice here is you're always better off if you can get everything equal to 0 and factor and solve. You see how we only wound up with one solution, and there should be two. Okay, I got another request here just in the nick of time. Thank you. Number 77. All right, number 77 will be next. By the way, if I want to just repeat, I forgot my power supply and my battery. I'm on battery, and I think it's going to work, but I may die at the end here if I suddenly disappear. It could be due to that. So 77. Find the difference quotient and simplify your answer. This is a different kind of difference quotient. I did the full difference quotient here. So let me look at that first, and then I'll do it over again, doing way. Maybe I do have it here. Yeah. Let me do it the book way, because that's what they asked for. And then if you want, I can go back and we'll just do a full. So we're given the x squared minus x plus 1. We're supposed to find this. All right, so in order to do that, we need f of 2x plus h, and we need f of 2. So I went about finding those. How do you find f of 2 plus h? Plug in a 2 plus h in the original expression wherever there was an x. That's what I've done here. And here I expanded it. And here's what it simplifies to. So now that I have f of 2 plus h, I need f of 2. Well, that's a little easier, and that just comes out to 3. So now plug them in. Here's the f of 2 plus h right here. And then here's the f of 2. So subtract them and divide by h. Well, on top, the 3's wipe each other out. And you can see, I hope, that you can factor an h out of the top. The h's cancel. Final result, h plus 3. Now, just even though you didn't ask about it, if you do a full normal difference quotient, that is when you're seeking to find this, then the problem looks like this. You first find f of x plus h, and you already know f of x, so you don't have to find that, and then just plug it in, simplify. Once again, the h's cancel. Final result. So because I might have gone off it too quick, let me just go back. Here's the 77 in the book, the way the book wanted it done. Okay, thanks for the 2 requests. Any other requests coming my way? Send them on. Otherwise, I'm going to pick another problem. I don't know. How about if we do... Let's do another one from that section. How about if we do 81? That one might be a little too tiny. Maybe, hopefully you'll be able to see this. Okay, 81. Again, here's what they ask you to find over here on the right. And here's what the function is. So we got to find, we already know g of x. All we got to find is g of 3. I see another request just came in. Here's the g of 3. In fact, I think we did this one in class, didn't we? Anyway, so in order to proceed, we need a common denominator. This one's looking familiar. I think we did this in class the other day. Okay. I am going to, we have a request for number 85. So that's the one I'm going to do next. 85. So anyway, I'm pretty sure we did this in class yesterday, and I had to get a common denominator in order to combine the 1 over x squared minus 1/9, which you see I did over here. You can combine 2 and then think of x minus 3 on the bottom as being x minus 3 over 1, and then invert, multiply, and the rest is pretty simple algebra. So 85 is next. And then I've got another request. Let me write these down here. So we've got 85 is next. And okay, so we got a whole bunch of them here from Alexandra. Let me see. 73, 77, 85 I'm about to do, 93, and 97. Thank you, Alexandra. So we'll see how many of those we can get done. 85 is next. Okay, so here we go with 85. Maybe. Do I have it or not? Yeah. Okay, so here's, I don't have it labeled. Let me write it on there. This is number 85. So in 85, we're told that you have a square which has a perimeter of p. So I sketched a square here, and we got to call the sides something. They're both identical because it's a square, so I'm calling it x by x. And then to bring in what the book gave us, it says the perimeter is equal to the distance around. Well, in my case, that would be x is 4 times, so 4x. And then what? We could solve this for x, and now I have an expression for x with respect to p. Well, why is that important? Because it said, write the area as a function of the perimeter p. So in other words, p is the variable we want. So how do you find the area square? Length times width, p over 4 times p over 4. And, you know, you could just write it like this then. F of p equals p squared over 16. Just squaring out the p squared, the p over 4. Okay, so that's number 85. Now 73. Go back to do that unless I don't have it, and I don't. So we'll just provide it. Okay, so let's put a page in here. And we're working on number 73 now. Okay, number 73. Oh yeah. Okay, so I don't have time to write the whole thing out, but do you see up at the top you have 3 functions that you can pick? I guess I'll quick write them out. One of them is just a constant times x. The second one is the square root of the absolute value of x times a constant. And then the last one is c over x. All right, so as you start looking at number 73, look at the ordered pairs. When x is -4, y is -32. So could that fit the first model up here at the top? Well, if it does, what do we have to multiply by -4 to get -32? 8, right? So that means if this is the problem, c would equal 8. So does that work for the second one? If you take -1 times 8, do you get -2? No. So that oh wait, we're supposed to square x. I apologize. I made a little mistake there. So let me do this one more time. So when you have x is -4, you get -32. So first, according to this, I copied this wrong. This is supposed to be cx squared. That's why I goofed it up. So first, square 4. When you square 4, -4, you get 16. What times 16 equals -32? -2. Okay, now let's try the second one. -1. If you square it, what do you get? 1. What times 1 equals -2? Yeah, see how that works? Let's try one more, way down to the bottom. What happens when you try 4? Take the square of 4, 16. If you multiply by a -2, do you get -32? Yep. So we just found for number 73 that this is the function. It's that first one. And we found c was -2. So this would be, what they were looking for. Which function does it match? And if so, what's the constant? So had that not worked, had we not found a pattern, then I would have gone on to look at the other two models up at the top. So that's the idea of 73. 77, I think I went through, but yeah, we went through this a little earlier, but here it is again. So this is on the video twice now, but that's okay. 77, x squared minus x plus 1 is the function. We're supposed to find this thing in the circle here, f of those. So before I can plug them into this, I got to find what is f of 2 plus h and what is f of 2. So I went through the process of finding f of 2 plus h. Plug in 2 plus h wherever there's an x, which I did, and I simplified it, and it came down to this. And then f of 2 came down to this. Now plug them in. Simplify the numerator, the 3's go away. Factor in h out. And you just get, there it is, h plus 3, final result. So I'm going to, you may have to rewind. Sorry, I'm going to go a little bit quicker on that one. But I had already done this a little earlier today in the video. The next request I have is for number 93. So I'm going to go over to 93. So 93 is one of these business problems. Cost, revenue, profit. So it says the company produces a product for which the variable cost, that means, $12.30 per unit. So you have to multiply that by how many units in order to get your cost. So 1230 times x. And then there's the fixed costs. That'll always be there, 98,000. So there's your formula for cost. And then the revenue, that's the amount of money you take in, is just $17.98 per item. So that's a pretty easy model. So I guess I've already done A and B. Now comes part C. In part C, find the profit. Well, profit, you take the revenue and subtract the cost. So all I did here is take the revenue equation, 17.98x, and from it, I subtracted the cost equation. And then if you just do a little algebraic simplification, that is combine the two like terms, the x terms, you should have your profit. And you notice I'm writing it in function form. Not real important, but anyway, the profit in relation to the variable x is, so if you take any number of items, let's say we sold 100 items, you could find out what your profit is by substituting a 100 in here for x and calculating it. So that's number 93. 97 has also been requested. So let's take a look at 97. I should write 97 on here. All right, so in number 97, in number 97, it reads, a balloon carrying a transmitter ends from a point 3,000 feet from the receiving station. So I'm saying this is the receiving station over here, labeled RS. And if you go 3,000 feet over, the balloon goes straight up from that point. And how high does it go? That I'm called, as the book says, let's let that be called H. Okay. And then it says D represents the distance between the balloon and the receiving station. So that's, you see how I've labeled that D. Well, hopefully, it said the balloon went straight up, so we know there's a right angle here. So you should see, oh, this is a right triangle. So the Pythagorean theorem applies. So I wrote out the Pythagorean theorem, one leg squared plus the other leg squared equals the hypotenuse squared. And the whole idea was for you to find the height of the balloon as a function of D. So solve for H. So I subtracted 3,000 squared from both sides. And then to solve for H, took the square root. So there we go. F of D equals the square root of D squared minus, and I should have really figured this out, but you guys can do that, 3,000 squared. So that's number 97. Any other questions come away? I think I've hit the ones that I've seen, but let me know. All right. Well, we'll start. Let's take a look. Let's see how my battery's doing here. I'm down to 52%. I think we're gonna make it. So I'm gonna give. We're gonna get a start on the new lesson. Again, anybody else have a question? Send it my way. So here's lesson 2.3, analyzing graphs of functions, and you can see from the list what it is we're trying to do here. We have 4 objectives. The first one is vertical line test. I think you guys already know that. We use the vertical line test to find out if it's a function or not. The second one is finding the zeros of a function. You already know how to do that, maybe just not the naming of it. To find the zeros of a function, all you're trying to find out is where does it cross the zero line? In other words, what are the x-intercepts? So that second objective is not new. Looks like I might have just had a question come in. Let's take a look. I do have a question on number 89. So I'm going to take a little time out and I'm going to zip back. Got another question here on number 89. Okay, yeah, this is a little bit of a stinker. This one's going to take a little while. All right, number 89. Right triangle, yeah. So you got to look at the diagram. I guess I have the diagram duplicated up on the slide here. That first diagram. The object is the right triangle is formed from the first quadrant by the x and y axes and the line through 2, 1. I didn't put the 2. I'll just stick it on here in red. So there's a point somewhere over here that actually is 2, 1. That I didn't have on the picture. Okay, otherwise I think I have the diagram right. Write the area of the triangle as a function of x. Yeah, so this is kind of a sticker. Of course, the area of a triangle up here in the right, BH over 2. And for me, the key was finding the slope. I mean, these are obvious. You got y-axis is vertical, the x-axis is horizontal, but you know what angle this is on is going to make a big difference. So I went ahead and let's find the slope. And first I used the 0B and the A0 point. So if you just take this point right here, point 1, and this point right here, point 2, plug them into the slope formula, you get the slope of minus B over A. Then good old y equals mx plus b, plug in the slope, okay? And by the way, I also plugged in the y-intercept. Look, you see that the y-intercept, where does it cross the y-axis? Right here. How high is that? Oh yeah, that's b. So normally b is just a generic number for the y-intercept, but now that's actually it. Okay, and then I plugged in the only point we actually know all numbers for, and that's the point 2, 1. So I plugged in 1 for y, 2 for x. Okay, that gives me this. And then so that I could simplify this a little bit, I multiplied both sides of this equation right here by a, giving me this. And then I solve for a. And so what I did is I factored out a b on the right side, and that gave me this in parentheses. And then to solve, I'm sorry, I solved for b. And then I just divided both sides by negative. So now I have this new expression for b. B is equal to that. So now I can get rid of one of those two letters, A and B. All right, so with that in mind, come back over here now. And now let's use the area formula to find the area. So area equals base. The base is A, right? From here to here is A, times the height. And I just found a new answer for the height, B. It's this thing, A, you know, the thing we just found. Base times height divided by 2. So that simplifies down, and, you know, we got down to here. And we're really there. I mean, the only thing left to do is, you notice how, I mean, this is the point x comma 0. How far to the right did we go? So in this problem, x is the same as a. And so just write the same thing over, only this time put an x in it. We got it. That one was a little bit tough because we had to, you know, we had to horse around with that a and b and get rid of one of those letters, which we did down here on the bottom on the bottom right, when we solved for B in terms of A. So that's number 89. Now, get back to where we were here. Yeah, we were talking here. You can still send requests, that's fine. But back on, so anyway, and then the third objective is where we were. We had already looked at these two. The third objective, determine the intervals on which a function is increasing or decreasing. So when is a function going up? You can just, if you have a graph, you can just see it. Between here and here, the function is going uphill. When is it decreasing? When it's going downhill. Okay, over what interval did it go uphill? You know, using interval notation. That's the kind of thing we're going to do there. And then finally, we're talking about even and odd functions. So let's see how far we get. Let's see how we're doing on the battery. I'm down to 46%. Okay, on we go. We're still recording. So just a reminder, a function, remember how a function looks when you look at ordered pairs? No value of x will have two different values of y. So you might wonder when you look at this point and this point, those 2 points both have the same x. Normally that's a no-no, except you notice they also both have the same y. So in other words, these 2 points are really identical. They're really not 2 different points. So we're okay. In no case does one x give us 2 different y's. So that's a function. Now look at the second set of points in red. 2, 2, 2, 7, 2, 9, 2, 2. Why is this not a function? Because we have more than one y for the same x. You know, here all the x's are 2, and you notice we have 3 different results. We have a 2, we have a 7, and we have a 9. No way, in a function that'll never happen. And the reason, if you plot these points, they're all right on top. They're vertical from each other. This is a vertical line. And a vertical line is what? The only line. A vertical line is the only line that is not a function. Put the line on any other angle and it'll be a function. So only vertical lines, I mean, that's the only kind of line that's not a function. All right. So the vertical line test, I think all of you know, if we take these 2 graphs in black and you pass a vertical line through the graph, will it ever cross the graph in more than one point at a time? And obviously it does in this squiggle on the left. It passes it, what, 4 times? You know, we got 4 crossings here. So that's obviously not a function. And this one fails too because it's got 2 crossing points. So the vertical line test is pretty easy, and I'm sure you've used that before. Yeah, and just a point, and these are all, think of these all as separate. If we take a look at this one down here in the bottom left corner, does that pass the vertical line test? Well, the answer is yes, because even when you pass a line through, yeah, here, let me take this line right here. And let me make it some other color here. Let's make it green or something. So if you take this line and pass it through the graph, will it ever, it never, even here it's okay, because here it crosses, you know, it only crosses 1 point because that top point is empty. So that's still okay, okay. So this is a function. Now when we, and this one above it here, this is not quite vertical here, so I think we're okay in this section. Only one, so that's all right. Now let's come over to this crazy thing over here on the right, and this is going to fail. It's going to fail right there, isn't it? We've got more than one crossing point. So, and it fails over here too, more than 1 point. So the good old vertical line test, I'm sure you remember, is valuable if you have a graph determining if you have a function or not. Okay? Yeah, so these are just other examples of functions. I don't have the vertical line, but I think you can see they all pass. This is the only one up here. This one right here in the corner is the only, I mean, this one here is not a function, right? If we pass the vertical line through that. But even the, so this is a pretty famous function here, absolute value. That passes the vertical line test. This is a famous function too, the reciprocal function down here in the bottom right corner. That passes the vertical line test. Okay, so just some more practice on using the vertical line test. What about the cubic function? Yeah, that's going to pass the vertical line test too. So we should be okay there. So now I need to introduce to you the difference between an even function and an odd function. An even function is a function that has vertical symmetry, the symmetry, you see how if I put the y-axis in a parabola right down the middle, the left and the right side are symmetrical. That's what an even function looks like. It's symmetry with respect to the y-axis. So when you change the sign on x, the answer for y doesn't change. So for example, when you take x squared, if you take the point 2, what's 2 squared? 4. All right, now take the same number with a negative sign. What's negative 2 squared? It's still 4. So it's that test. We had the symmetry test before, right? If you take a value for x and then take its negative, does it change the result? In this case, no. And if you test it 2 or 3 times and it works, it means you've got an even function. But we've never really looked at this. Well, you remember origin symmetry? Well, origin symmetry, this is another test you've already had. We didn't call it this, but that's called an odd function. Now, a little bit of caution. You notice how even functions have the even exponent up here, x squared, whereas the odd function has the odd exponent. Oh, be cautious though. Just that doesn't always work, because if you have a more complicated odd function like x cubed plus 2x squared minus 4x, that you got to be careful. So you got to run the test. And do you remember how to do the test on origin symmetry? Plug in a number for x and then cube it or whatever the function is. Get that answer. Change the sign on x, use the same number. Do you get the opposite answer you got before? So for example, let's take 3. What's 3 cubed? 3 times 3 times 3 is 27. What happens when you plug in negative 3? Well, a negative times a negative times a negative is a negative. So you see how when you change the sign on x, you get the same number, but the opposite sign on y. That's a sure sign that you have an odd function. Of course, again, make sure you got to test this at least 3 times, okay? Now let's take another one. What happens when you cube 2? You get 8. What happens when you cube negative 2? You get negative 8. And then just test it a third. So anyway, you really knew these. We just didn't call them by these names. So y-axis symmetry, even function. Origin symmetry, odd function. Okay. Yeah. Now, here's the reason I'm showing this. When we get some of you may have had trigonometry, some of you haven't. But anyway, what I've sketched here is part of the y equals cosine curve. Do we have any kind of symmetry here? And you should be able to see that even though you haven't seen the rest of this graph that comes over here to the left because we have room, it matches up. It's got y-axis symmetry. So this is an even function. But did you know there's not even an exponent? So here's what I was trying to tell you about that. Don't just look for the exponent and say, oh yeah, it's an even exponent, so it must be even. Sometimes you have no exponent and it's still even. So be careful of that exponent shortcut. It does not always work. Okay. Okay, so here's a problem from the assignment, number 32. Let's talk about this increasing and decreasing. So in your books, number 32, I got to get there. So open your books to page 208. And I didn't have a time to put the graphic in here. But if all of you will look at your books on page 208, look at number 32 and you'll see there's a parabola there. And all we need you to do is to eyeball, when is this function decreasing? When is it going downhill? Well, it's going downhill on the left side, right? And as you know, parabolas go forever up. So that left side starts at what? Negative infinity, and it's going down until we get to x equals 2. So do you see how I wrote that here? That function is decreasing from negative infinity up to, but not including 2. That's why it's got a round parenthesis. Where is it increasing? Well, from 2 and forever to the right. So not at 2. Technically at 2, it's neither increasing nor decreasing. It's at a little finite resting point, I guess. But anyway, after 2, it's going uphill. So that interval would be listed as 2 comma infinity. So that's just an eyeball exercise, right? Do you see that? Let's take a look at number 20. I don't know what this is. I don't actually know where this is from, but this is an example of testing for symmetry. Okay. So I've got this function x cubed. Is that an odd function? Well, try a number. I tried 2, and then I try the negative of that same number, negative 2. Do you get the same number with the opposite sign? Yep. Does that work? And then try it again. I did it twice. I should really do it 3 times. And then come down here and look at this one here. Looks like it's got even exponents. So might it be an even function? Well, let's find out. Let's plug in a number, 1. What happens? 1 to the 4th is 1. And 1 minus 2 times 1 squared is, 1 squared is 1. And 2 times 1 is 2. So this becomes 1 minus 2, which is negative 1. What happens when you plug in a negative 1? Well, you come out with a negative 1 again. So notice this time when you change the sign on x, y stays the same. Does that work? I did it again with 2. Yeah. So now you see. This is just a visual practice of how do you find out which kind of symmetry a graph has? Okay. So that's kind of it for today. My battery is getting pretty low. What I'm going to have you do is start on the assignment. Okay, so let me just make a slide here and write that down. So starting exercises for 2.3, so 2.3 assignment. I'm going to need another day on this, but I want to get you started on it. So let's, I don't know, just see how far you can get on the odds. So I'm not going to give a specific one. Probably it's going to be all the odds, but right now, just start on one and see how far you can get on working through the odds. And then when we start class on Friday, we'll pick it up with that, and I'll do some more instruction on this, and then the actual assignment should be ready to go by Friday. Okay, well, thanks for your participation. If you have any more questions, still send them my way, either by email or by text. Oh, I see. Oh, yeah, we did go through 89. Okay, I'm not seeing any more questions at the moment. thank you for your participation. I appreciate it very much. I will see you on Friday.